Good morning. Today we will talk about mass and weight. What is mass and what is weight? First, I will start talking about weight. What do we mean by weight? Okay, what happens when we release an object? I want you now to hold a pen and release it. Of course, you will notice that the pen will fall down. Okay, what is the line of action of falling down? It is vertical and the direction is downward. Why the pen or any object falls down when we release it? Because it is attracted by the center of the earth. This attraction is called gravity أو نقصد فيها الجاذبية. The action of gravity on the object is the weight of that object. So any released object falls down following the vertical line of place where it is located. So as you can see, when we release an object, it will fall down like this in a vertical line of action. So it will fall down in a vertical line of action. And this is the center of the earth. If we want to measure the weight, we use a special instrument. This instrument is called dynamometer. The dynamometer, as you can see it in this figure, okay, it is used to measure the weight of an object and it has an index. This is the index. Let us see here the weight of the blue object here is 20 because the index is at 20, and here the weight of this red object is 30. You notice that near the weight we write an or a Newton, which means that the unit of the weight is Newton. So the weight here is 20 Newton and the weight here is 30 Newton. So any object released in air falls down following the vertical line of the place where it is located. It is attracted by the gravity of the earth. Okay, so these objects are attracted by the gravity of the earth or any released object also. The earth attraction on the object is this object's weight. So weight is related to gravity. An object's weight is measured with a dynamometer and expressed in the international system in Newton. So the unit of the weight is Newton. Now, does an object's weight vary? Let us see from this figure and conclude if the weight varies or not. On the surface of the earth, the weight of the man was 616 Newton or 680 Newton. Let us see what happens to this weight as he gets far from the earth. When as you can see, the weight decreases from 680 Newton to 27 Newton as he gets more far from the earth. So at the surface of the earth, his weight was 680 Newton. At the altitude of 224,000 kilometers, his weight became 27 Newton. So the weight decreases a lot as he gets far from the earth. So the weight is related to gravity. As gravity decreases, the weight decreases, and vice versa. As gravity increases, the weight also increases. Now I want to see the mass of the man. Does the mass of the man vary? Let us see. At the earth, the mass of the man is 70 kilogram and his weight is 700 Newton. At the moon or on the moon, we notice that his mass remains the same, 70 kilogram, but his weight decreases to 100 Newton. What does this mean? This means that the mass doesn't change, it remains the same. So the mass doesn't depend on gravity, because on the earth it is 70 kilogram and on the moon it is 70 kilogram. But the weight, as we said before, depends on gravity. Why? Because the weight of the man on the moon is 700 Newton, while the weight of the man on the earth, is 700 Newton, while the weight of the man on the moon is 100 Newton. So we notice that the weight depends on gravity. It decreases as gravity decreases, but the mass doesn't change. Okay, of course, the mass is the quantity of matter in the object or in the man. Okay, the mass doesn't change, it remains the same in the earth and on the moon. So as a comparison between mass and weight, mass is the quantity of matter contained in the object, while the weight is the force, the attraction force exerted by the earth on this object. So the weight depends on gravity, but the mass doesn't depend on gravity. That's why the weight varies while the mass remains constant. Okay. So as we said, the mass of an object does not vary, it remains constant, while the weight of an object varies. What about the measurement? We all know that we measure our mass using a balance, and we all know that the unit of the mass is kilogram, while we measure the weight by a dynamometer, and the unit of the weight is Newton. And we know, if I want to calculate weight, I use the formula. Weight is equal to mass times gravity. And now I'm going to give you an application. And now, as an application, how can we calculate the weight of an object? Of course, I use a formula, weight W equal mass times gravity. So weight W, the unit is in Newton, equal mass the symbol is in kilogram, the unit, times G, gravitational force. Okay, and this gravitational force depends on the planet, of course. G, gravitational force, the unit of the gravitational force is in Newton per kilogram. Now I have this question: calculate the weight of an object placed on a table, of course on Earth. Given G, gravitational force on Earth, is 10 Newton per kilogram, and the mass of the object is 1 kilogram. Be careful, the mass should be always in kilogram. You can't use the formula only if the mass is in kilogram. Now we start writing the formula. Weight equal mass times gravity. I write the unit Newton, kilogram, Newton per kilogram. Weight, I need to know the weight. So I multiply the mass with the gravitational force. The mass is 1 kilogram. So I substitute with 1 kilogram times G is how much here? 10 times 10 Newton per kilogram. So the answer will be 10 Newton. So to find weight, I need to multiply the gravitational force with the mass of an object, and the mass should be in kilogram.